In this lesson, you will learn how to graph linear inequalities in two variables. Graphing linear inequalities involves two simple steps. The first step is to graph the boundary line. The second step is to shade the solution region to show all points that satisfy the inequality. To graph the boundary line, start by replacing the inequality sign with an equal sign. This changes the inequality into a linear equation. Here, the equation is in slope-intercept form. The easiest way to graph an equation in this form is to use the slope and y-intercept. The slope is the coefficient of x. The y-intercept is the point 0, b. For this equation, the slope is 2/5 and the y-intercept is 0, 1. Now, plot the y-intercept on the coordinate plane. Then plot another point using the slope. Slope is rise over run, and here it is 2/5. When the rise is positive, we move up, and when it's negative, we move down. Here, the rise is positive 2, so we move up 2 units. When the run is positive, we move to the right, and when it's negative, we move to the left. Here, the run is positive 5, so we move to the right 5 units. Now, start at the y-intercept and move up 2 units. Then, move to the right 5 units, and plot the second point. Finally, draw the boundary line that passes through these points. If the inequality is less than or equal to or greater than or equal to, use a solid line. A solid line means points on the line are part of the solution to the inequality. If the inequality is strictly less than or greater than, use a dashed line. A dashed line means points on the line are not part of the solution to the inequality. In this example, the inequality is less than or equal to, so draw a solid boundary line. That completes the first step. The next step is to shade the solution region. To do that, first pick a test point that is not on the line. A great choice is the point 0, 0, since it is easy to work with. Then, substitute its coordinates into the inequality and simplify. 2/5 times 0 is 0, and 0 plus 1 is 1. Since this is a true statement, the test point satisfies the inequality. That means our test point is part of the solution region. If the test point makes the inequality true, shade the region that contains the test point. If the test point makes the inequality false, shade the region that does not contain the test point. Here, since our test point makes the inequality true, we shade the region containing the test point. That's your graph. Every point in the shaded region and on the boundary line is a solution to the inequality, while points in the unshaded region are not. Now let's work through an example with a strictly less than inequality. First, graph the boundary line by replacing the inequality sign with an equal sign. Like the previous example, this equation is also in slope-intercept form, but has no constant term. This means b is 0. So the slope is negative 1/3, and the y-intercept is 0, 0, right? Now, plot the y-intercept, which is at the origin. Then, plot another point using the slope. Slope is rise over run, and here it is negative 1/3. Place the negative sign in the numerator. This doesn't change the value of the slope since they are equivalent fractions. So the rise is 1 unit down, and the run is 3 units to the right. Now start at the y-intercept and move down 1 unit. Then move to the right 3 units and plot the second point. Finally, draw the boundary line that passes through these points. Since the inequality is strictly less than, use a dashed line, which means points on the line are not part of the solution. The next step is to shade the solution region. Pick a test point that is not on the line. Since 0, 0 is on the line, we can't use it. Instead, let's use the point 1, 1. It's always best to choose a point that is easy to work with. Now substitute the coordinates into the inequality and simplify. Since 1 is not less than negative 1/3, this statement is false, right? That means the test point does not satisfy the inequality, so it's not part of the solution region. Therefore, we shade the region that does not contain it. That's your graph for this example. Every point in the shaded region is a solution to the inequality, while points on the boundary line and in the unshaded region are not. Now let's move on to an example where the inequality is in standard form. As always, first graph the boundary line. Replace the inequality sign with an equal sign. This equation is in standard form. The easiest way to graph an equation in this form is to use the x and y intercepts. So, we start by finding the intercepts. Remember, the x-intercept occurs when y equals 0. So, set y to 0 and solve for x. 5 times 0 is 0, leaving us with 2x equals negative 10. Now, divide both sides by 2 to isolate x. This simplifies to x equals negative 5, right? Therefore, the x-intercept is negative 5, 0. This is where the line crosses the x-axis. The y-intercept occurs when x equals 0. So, set x to 0 and solve for y. This simplifies to 5y equals negative 10. Dividing both sides by 5, you find that y equals negative 2. Therefore, the y-intercept is 0, negative 2. This is where the line crosses the y-axis. Now plot the intercepts on the coordinate plane. The x-intercept at negative 5, 0, and the y-intercept at 0, negative 2. Finally, draw the boundary line that passes through these points. Since the inequality is greater than or equal to, use a solid line. As you've seen so far, no matter the form, graphing inequalities always starts with graphing their related linear equations. So, mastering how to graph linear equations is key. If you need a refresher, check the links in the description. Next, to determine which region to shade, pick a test point that is not on the line. You can use 0, 0. Substitute it into the inequality and simplify. This is a true statement, right? So shade the region that contains the test point. That's your graph. Now it's your turn. Pause the video and graph the boundary line. Start by finding the x and y intercepts. The x-intercept occurs when y equals 0. Set y to 0 and solve for x. This simplifies to 4x equals 12, right? Dividing both sides by 4, you get x equals 3. So, the x-intercept is 3, 0. The y-intercept occurs when x equals 0. Set x to 0 and solve for y. This simplifies to negative 3y equals 12, right? Dividing both sides by negative 3, you get y equals negative 4. So the y-intercept is 0, negative 4. Now plot the intercepts on the coordinate plane. The x-intercept at 3, 0, and the y-intercept at 0, negative 4. Finally, draw the boundary line. Since the inequality is strictly greater than, use a dashed line. Next, pick a test point that is not on the line to determine which region to shade. You can use the point 0, 0. Substituting it into the inequality and simplifying gives 0 greater than 12, which is false, right? So shade the region that does not contain the test point. That's your graph. Almost done. Now, let's take a quick look at cases where the boundary line is horizontal or vertical. As always, the first step is to graph the boundary line by replacing the inequality sign with an equal sign. The graph of y equals negative 2 is a horizontal line crossing the y-axis at negative 2. Since the inequality is strictly less than, use a dashed line. Next, shade the solution region. Pick a test point that is not on the line. You can use the point 0, 0. Substituting it into the inequality gives 0 less than negative 2, which is false, right? So shade the region that does not contain the test point. That's your graph. Now, what if the boundary line is vertical? You still need to follow the same steps. The graph of x equals 0 is a vertical line crossing the x-axis at 0. Since the inequality is greater than or equal to, use a solid line. Next, pick a test point that is not on the line to determine which region to shade. You can use the point 1, 1. Substituting it into the inequality gives 1 greater than or equal to 0, which is true, right? So shade the region that contains the test point. That's your graph. By the way, this channel has step-by-step lessons on solving systems of linear equations using substitution, elimination, and the graphical method. You'll also find lessons on solving quadratic equations by factoring, completing the square, and the quadratic formula, as well as quadratic inequalities and graphing quadratic functions. Plus, there are lessons on finding the domain of a function, polynomial long division, an introduction to trigonometry, and much more. Check the links in the description to explore them all. Give it a thumbs up and consider subscribing.